I would like to welcome our local expert, Assistant Professor Or Aleksandrowicz, please. Dr. Or Aleksandrowicz is an architect, researcher, and academic whose work bridges architectural history, building science, and urban climate design. As head of the Big Data in Architectural Research, BDAR Lab, is developing urban shade maps that help municipalities in Israel adopt data-driven strategies to mitigate heat and enhance public spaces using GIS and climate monitoring. His work supports sustainable, climate-responsive urban planning. Thank you.
Wow, Jonathan. He wrote it himself. I didn't get it. So, first of all, I have to thank Jonathan for the invitation and for this great occasion with unbelievable guests and audience. It's totally not trivial to see everybody here. And also, where's Nada? Nada and Ilan, thank you very much for all your help during the day. I'll be very focused in my presentation, and I will be talking about urban climatology and maybe the weak spots of how we, as let's say, urban climatologists, or have been until now, be looking into what is actually the climatic challenge of many cities. And coming from, I'm an architect, but I'm coming from urban climatology. Usually, and this is what almost everybody knows, we're talking about the magnificent urban heat island and how we can mitigate it in one way or another. And the question is whether this is actually a valid concept. And actually, as designers, can we do anything about it? There are many problems with this concept. First of all, how do we map it? And there are several definitions of what an urban heat island is, and you can see both here. What is the scale of resolution that we're looking at? And if we're talking about high resolution using, let's say, satellite imagery, it's not really something that connects to people walking down the streets. And in the end, using all this sophisticated data, you end up with understanding that trees cool down urban environments, and you don't have to invest so much time. And even if you, create models or using sophisticated satellite imagery, the question still is how designers and architects can actually use this. And here you see examples of two urban heat island mapping of different times, different methods. And if you give it to an architect or to an urban planner and try to elucidate something intelligent out of it, it is very hard because they are totally different when you try to interpret them. So if we are really interested in producing change, and we need change because our cities are not very well adapted to heat. The question is whether the urban island is actually a valid concept, and the short answer is not really for many places. What we should be looking at is actually heat stress, and it was mentioned here during the day. And if we try to minimize or to focus on what actually makes the difference, and it makes a difference between sensing and moderately heat during summer to excruciatingly heat stress. This is actually ends up with telling everybody that we should provide more shade. So everybody understands that the difference between these two pictures actually ends up with very, very different perceived heat. Now, this is not something new, of course. And we have a biblical story of Jonah that actually tells totally the same story. But we have more, let's say, sophisticated tools and sophisticated scientific methods to actually put numbers into it. And using this, for example, universal thermal climate index, and we know that it takes into account the effect of solar exposure and gives a very valid weight. And then you go out. Not just using models, go out and see what really happens when you measure this MRT, this mean radiant temperature. You end up understanding the main difference between the feels like temperature or the perceived temperature doesn't stem from any change in air temperature, okay? So you can get a dramatic reduction of heat stress by providing shade. Well, how dramatic? It can be several, up to 10 degrees during the summer, depends on what scale you use. And more interestingly, in the spring, in the autumn, you may see a much higher difference. So we're talking about summer all the time, but as things are warming up, we should think more also about springtime and autumn. The good thing for us as designers is that unlike many other climatic phenomena, especially the urban heat island, that we can do almost nothing about, almost nothing, except putting trees everywhere. Shade is actually something that we are totally responsible, 100%. If we don't design shade, there won't be any shade probably, or the shade won't be enough. And funny as it seems, this is not an insight that is very prevalent among urban climatologists. So putting shade in front of anything else is actually something quite new. The question is not just telling everybody put more shade now. The question is how we can quantify this and map this to make designers actually use our scientific insights. And this is let's say, a huge challenge. Now, basically, you would say, okay, we'll have these very sophisticated CFD tools. Let's simulate everything and simulate every different design scenario that we think about. We have a problem. We have a problem here. We have two problems actually with these CFD tools. First of all, it takes a lot of time and effort to produce very small scale simulations. So you cannot simulate the entire city efficiently. And the second thing is that the results are not very reliable, especially when you look into mean relative temperature and heat in general. It is very well documented and totally ignored by many people who use these tools. So we have to think of much more effective and efficient ways, and here comes the shade mapping concept. This is something that I've been working on for several years now. Started with the work in Tel Aviv, but now expanded to right now 15 cities in Israel. And the idea is very simple. We can actually efficiently calculate high resolution shading conditions in cities using a specific shade index, which is very easy to understand. It moves from 0 to 1. And when you create such a metric, you have to have some basic assumptions very clearly stated. So we do have to think what is the exact reference standard we're looking into. Okay, the reference space is very simple. We are talking about streets. Now, when do we have to calculate shade? This is we don't have a scientific answer for this. This is something that should come from the field. And the answer is that we should look into the height of summer, 6th of August to be more precise. And we have the fortune because of how the Earth revolves around the sun, that 6th of August and 6th of May are totally identical in terms of shading. So it also, same shading index also applies for spring. Now, it's a nice idea. The question is how we can process, again, efficiently these maps. And we developed a GIS-based tool based on open source code, but also some of our developments. And we actually take these 6th of August, 10 hours in a row, add them together, so you have like a clear understanding of what happens during the entire day. And then the question is how you move from this impressionistic map to something that you can actually work with. And the addition is that we have to average these numbers into street segments. So if we do it, we can have some clear hierarchy of shade in every street segment in the city, and then to highlight which street segments are better shaded and worse shaded. And we can do it, of course, for cities, as you can see here. Because of the way we're doing it, we can very nicely understand the difference between a city that is well shaded through buildings and trees, and what happens if we take out trees out of the city. You can see the differences. As you can see, there are some streets that can get moderate shade even from the buildings without any tree. So it's not always about trees, it's also about how you design buildings. And urban morphologies, you can also do it on a larger scale if you would like to. You can integrate it into 3D models to better understand actually the relationship between how you design cities, how you design or how you maintain urban forests, and the resulting shading conditions. Now it's very fine. Now, how can we use it? And I'm going to show you a very hard and problematic city to work in. And this is Eilat. Eilat is a desert city. It's the southern point on the Israeli map. And to begin with, it starts with very, very hot weather, which is getting worse and worse. And actually, the idea of springtime relief is no longer with us in Eilat, because everything goes up. How streets are designed in Eilat, something like this. You can ask yourself what went wrong. So why designers, why architects in Eilat assume that people won't use streets any way around except by driving cars? They actually provided good shading for the cars. But the fact is that beyond asking these questions, we have to work with city that is almost totally unshaded. Now, we have this nice map drawn. You can see that there is some improvement because of trees, but this improvement is not really great, as you can see here. If you try to prioritize what's really happening, you end up with almost any street in Eilat that suffers from extreme lack of shade. You cannot answer, or you can give straight answer about which streets to begin with just by looking at these scientific measurements. It's not enough. We cannot use only our data to answer questions which are essentially political. And to do so, to try to use these maps somehow in a way more beneficial, we have to engage with some kind of a negotiation with the planners and with the municipality to understand what is important for them. It is not done by computer models. You have to talk to people, you have to negotiate with them, and you end up with kind of a map that actually prioritizes where they want to put the money first to improve shading conditions. Okay, how much time do you have? I think 2 minutes. 2 minutes, okay, great. So I'll end up by going to the last phase, which is the design phase. So we're talking about mapping. Mapping is very important. You have to prioritize, and prioritization is not something that is 100% say data dependent. And now the question is how you design for shade. And for this, we done a very thorough work and published these guidelines for applying all kinds of shade quantification indicators. And for designing shade, we understood that the shading that we're using, which is based on hard calculation of solar exposure, probably won't go well with designers. So we try to make it simple, to simplify this, and to get into a concept that talks about time and not about actually, the amount of solar exposure that you're getting. And this is the shade availability index. It's very, very simple. You're looking at the same time during the year. But you're trying to quantify how many hours during the day you get about 50% shade or more on the sidewalk. So because you're doing this way and not by going into very sophisticated, let's say, UTCI and thermal comfort indices, you can create also a kind of normative scale that translates very easily to the years of a design. So if we're talking about 0.5, we're talking about 50% of the time during our day. This is something that we can communicate and we can also negotiate. Last word. When you map many different cities, map the shading at many different cities, you start to understand that it's not all about morphology. It's not all about urban design. You see differences and you see discrepancies and you see inequalities that doesn't come from a specific, let's say, urban planning ideas or ideologies. You see also that poor cities suffer more from shade, from the lack of shade. So, and this is something to be thought of, you know, in the future, maybe in the near future. But by mapping, you can understand that. Okay, you try to understand why these places are made this way, why are they maintained this way, and how we can fix this, not just through design. Design is part of the answer, but it's not the only answer. That's all for now. Thank you.
Thank you very much. Or where this is a different mindset for our European guests who look for the sun, who value the sun and even protect it with their standards. And here there is a completely different and opposite perspective of, okay, we want to look for and extend shading. So probably you have interesting questions to ask or others. Yes, Steph.
Others. Thank you, others. I'm others. Is it working?
Yes.
Yeah, it's working. Thank you very much. I agree with you 100% that trees are better than other shading facilities. But I mean, when you're talking about these poor cities as opposed to rich cities, I mean, trees, other than being beautiful and supportive and giving us shade and everything, they need a lot of water and taking care of. So maybe also think about other possibilities for shading.
Okay, it's a very good point. Looking into shading. So the first frontier in shading should be buildings, because buildings are paid for by the private sector. Okay, so if you understand this and put this into your building codes, then you would end up with better starting position. The question of how you sometimes, many times you have to supplement it with external shading elements. And the fact is that trees, even though they are a bit expensive, they are not as expensive as any other artificial shading elements.
Okay.
And this means that we just have to find the money for better trees. Okay, that's all. I wanted to add something to what Jonathan just said. We saw here that, of course, shading is maybe not a huge problem in Denmark, but wind is. So the same approach is our approaches are not very different. In a funny way, there's an Austrian PhD student of mine that approached me because he was really concerned about the shading conditions in Vienna. And I was a bit laughing like you at first, but then I understand that the Viennese tolerance for shade, or for the lack of shade, may be a bit lower than ours. So they are less expecting this and less tolerant if they don't get enough shade during very specific times in the summer. And in such temperate climates, And we're assuming that these places are going to be a bit warmer in the future. There should be, it's more complex because you have to try to overcome two sometimes contradicting positions. You want to supply shade during summer, but also you want to make sure you have enough indoor illumination during winter. And this calls for a more sophisticated approach, and it's not, we're not there yet.
Thank you thank you for the presentation. I'm wondering, do you use some guess information about the tenants, about the distribution tenants to predict, for example, the corporatization of the a point where you need the shading or the to predict or recognize the journey of the people, something like this?
Well, originally in the work that we did with Tel Aviv, we actually used a space index model to try to prioritize where shade or where extra shading should be added. So first of all, understand where people should walk or maybe more readily walk. I'm not sure that's the only answer. I think the answers here also are stemming from, you know, some very specific considerations that are very specific to each city. So maybe there is a city that wants to highlight a certain area, put more money there. You know, as a scientist or as a designer, I'm not sure that I'm the one who should give the answers. I want to give more responsibility and accountability to these policymakers. So they know that, you know, the situation is not great. Please decide and please tell everybody why you decided so. Not just because some urban climatologists told you that people may walk more in certain area. We can do it. I'm not sure we should do it.
Thanks for your presentation. I really love it. I'm not really asking a question. I'm just providing another perspective. As I'm coming from an area background, from our chair, 2 years ago, there was a research about the trees in Zurich, and for the PV panels on the building facade, and when there's a shade, the way they function as to how the different panels are wired together will hugely reduce the yield. And that's side effects in for example in Zurich. Yeah. But I mean, this is relevant to your argument. I really like your argument.
It's very relevant, and I think the answer again won't be taken out of calculations and modeling. I think, let's say, if people of serious think that, you know, solar paneling is more important than outdoor shade, that's okay. I cannot say that it's right or wrong.
Yeah.
But they should understand that they should have some kind of a compromise or that or just decide for one strategy over the other.
Really nice presentation, and I fully agree in the perspective of, just out of curiosity, this question about water, the scarcity of water that we will see in the future. Will there be like a dilemma of the water prices will go up? Should it be for the people or for the trees? So how do you navigate in that dilemma?
Well, this should surely be taken into account. And right now in Israel, and I'm talking specifically about not just about Eilat, which is a desert city to start with, also in Tel Aviv. Tel Aviv irrigates trees for 10 out of the 12 months each year. And the funny thing is that right now nobody is actually thinking about what is going to be the water price in 10 years from now, 20 years from now. It is not taken into account, and it should. Now, the other way around also is to put things in perspective. So the cost of trees, again, the cost of trees, the cost of water is actually not as high as many other infrastructure that we use around the city. So the question is how policymakers really understand that urban forest is actually a type of infrastructure that they should invest in. Right now, people tend to think that it's not an infrastructure, it's something nice to have, it's very pleasant to view, but it's not something that works for the city, for the climate of the city. And we try to educate people, but not always very successful.
Yes, Daphne.
I think it's,
Yeah, we hear you.
okay, this idea of collaborating with other ideas. Because city trees, urban trees, they also reduce stress. And it's so important. So, I mean, when you go to these, to the city, how do you say?
Just to city planners.
No,
City-
not to
city
the
planners
city,
are- city-
not to the city planners, but to the
Officials?
officials that
Officials.
actually decide on things. If they are, they really understand that and they agree, and then they see that there's like a double or three facets to that idea, then maybe that would make them decide.
Yeah, and it is very, very right to say that the problem lies not in our understanding, and even not in how we communicate this, but this is decided by city officials who really don't care much about trees, and we see it almost every day.
They don't care about the people.
It is, well, it is something that is beginning to change, okay? So when a politician, a local politician understands that trees can bring him or her something beneficial, probably he would put more
She
she
would.
or he would probably put more money into it. Right now, we're not, in Israel, we're not there yet. But things again are changing.
And maybe I'll ask the last question because I think it's great presentation and really thank you for that. And I want to maybe connect to what Jean-Ming said and maybe ask the same question the Austrian PhD candidate asked you, but from the perspective of a Tel Avivian living in Tel Aviv and walking, for example, in December and really looks for the sun. So in a way, if we can think about the next step of this dynamic map that also will look into this kind of winter sun, because we need to balance, this, it's always a trade-off. Even though I completely agree, and all my research as well, and we've been talking about it, shows that the main problem here is, of course, especially in places like Eilat, but also in Eilat, when you walk in December and you suddenly feel the sun, like a bit in Europe, right? It's great, it's a wonderful sensation. And maybe this balance will be an interesting way forward, but thank you so much.
Well, I have a very short answer. Buy a good coat. Actually, it's very hard to balance between the two. That's the main problem. So if you're exposing things for winter sun, you will probably end up in many places totally exposed also during spring and summer. And it depends what matters more for you as a competition.
Interesting. Thank you so much. I think it's a really interesting ending.